the head of NASA confirms 3I Atlas is not natural, and the alien object now moving closer to Earth.
The alarms weren't supposed to go off like that. Inside NASA's Deep Space Network, October 29th started like any other day. Then the screens lit up. A mountain-sized object from another star system, designated 3I Atlas, did the impossible. It fired. A concentrated beam, straight into the heart of our sun. In the silent control room, one scientist broke the paralyzed quiet. 2 words. Call everyone. What happened next would be buried under layers of classification. Until now. Rewind to 6 weeks earlier. The Atlas survey in Hawaii exists for one purpose: find rocks in space before they find us. Asteroids, comets, the usual neighbors floating through our solar system. But on September 13th, astronomer Robert Warwick spotted something that made him double-check his calculations. A faint blip, moving wrong. Too fast. Way too fast. Most objects in our solar system are gravitationally bound to the sun. They orbit. They follow predictable paths. This thing was doing 60 kilometers per second. It wasn't orbiting anything. It was passing through. An interstellar visitor. They named it 3I Atlas, the third interstellar object ever detected. And that's where the celebration ended and the questions began. The thing nobody tells you about interstellar objects is how rare they are. We've only confirmed 3, ever. The first was Oumuamua in 2017. Strange, cigar-shaped, tumbling through space. Then came Borisov in 2019. A normal comet, nothing special. But 3I Atlas? This was different. First problem, size. Initial observations estimated it at over 3 kilometers wide. That's not a rock. That's a mountain. Its mass clocked in at 33 billion tons. To put that in perspective, that's 1 million times more massive than Oumuamua. Second problem, composition. When the Hubble Space Telescope locked onto it in early October, spectral analysis revealed something bizarre. Most comets are dirty snowballs, water ice mixed with rock and dust. As they approach the sun, the ice heats up and creates a beautiful tail of gas, mostly water vapor. Not this one. The plume coming off 3I Atlas was almost entirely carbon dioxide. Weird, but not impossible. Then came the nickel readings. The nickel-to-iron ratio was completely inverted from what nature produces. You can see this kind of ratio in industrial alloys, in spacecraft hull plating, in manufactured materials, but not in comets. Third problem, and this is where things get truly strange, the jet. Comets have jets. Solar wind heats the surface, gas escapes, creates outward pressure. These jets always point away from the sun. It's basic physics. Radiation pressure pushes material outward. Hubble images showed a narrow, focused jet coming from 3I Atlas that was pointing toward the sun. Not away, toward. The jet was 10 times longer than it was wide. Perfectly collimated, like a laser beam made of matter. One astrophysicist called it a garden hose in a hurricane flowing the wrong direction. Impossible? According to known physics, yes. But there it was, on every telescope image. A cosmic impossibility, hurtling toward our sun at impossible speed with impossible composition, doing impossible things. And it was 3 weeks away from its closest approach. Nobody knew what would happen when it got there. But deep in those windowless rooms at NASA, some were starting to suspect this wasn't a visit. It was a mission. October 29th, 1347 UTC. 3I Atlas reached perihelion, its closest point to the Sun. Distance, 125 million miles. Every major telescope on Earth and in orbit was watching. Then it happened. The jet, that impossible sun-facing jet, intensified. Not gradually, instantly. Its brightness increased 1,000-fold in under 6 seconds. But this wasn't a chaotic spray of gas and dust. This was coherent, focused, a beam. For 11 minutes, 3I Atlas fired a concentrated stream of energy directly into the solar surface. The wavelength signature didn't match any known emission spectrum. The beam remained perfectly stable, perfectly aimed, as both the object and the Sun moved through space. To maintain that kind of targeting precision requires active guidance. Course correction, technology. Inside control rooms across 3 continents, the same realization hit simultaneously. This wasn't an observation. This was an event. Alarms screamed. Encrypted calls went out. Protocols designed for nuclear war were activated for something far worse. And then, as suddenly as it began, the beam stopped. 3I Atlas continued on its trajectory, already accelerating away from our Sun, leaving our solar system forever. But it left something behind. The panic didn't start with the beam. It started when someone asked the obvious question: where did this thing come from? Dr. Sarah Chen, orbital mechanics specialist at JPL, was the one who ran the numbers. She backtracked the trajectory, traced 3I/Atlas's path through space, rewinding its journey like a video in reverse. Space is big, incomprehensibly big. An object entering our solar system from interstellar space could come from literally any direction. Above the solar plane, below it, any angle across 360 degrees of possibility. The odds of entering aligned with the ecliptic plane, the flat disk where all our planets orbit, is roughly 0.2%, 1 in 500. 3I Atlas entered almost perfectly aligned with the ecliptic. Chen stared at her screen, ran the calculation again. Same result. But that was just the start. When she plotted the full trajectory, her hands stopped moving. The path wasn't just aligned with our solar system's plane. It was optimized. Close flyby of Mars, Venus, Jupiter, not random passes, optimal approach angles for observation, for scanning, for reconnaissance. She calculated the probability of a random interstellar object having this specific trajectory. The number came back, 5%, 0.005%. To put it mildly, random objects don't do this. Guided ones do. Chen picked up the phone, called her supervisor. We need to classify this, now. But she wasn't the only one running calculations. At the SETI Institute, Dr. Marcus Webb had a different question. He wanted to know where in the sky 3I Atlas had come from. Not just its trajectory, but its origin point. The direction it traveled from. He pulled up the data, marked the coordinates. Then, out of curiosity more than anything else, he cross-referenced those coordinates with SETI's historical database. His screen flickered. A match. August 15, 1977. The wow signal. You might know the story. If you don't, here's what matters. In 1977, the Big Ear Radio Telescope in Ohio detected a powerful narrowband radio signal from deep space. It lasted exactly 72 seconds. The astronomer on duty was so shocked, he circled it on the printout and wrote "Wow" in the margin. The signal was 30 times stronger than background noise. Its frequency, 1420 MHz, is significant because that's the emission frequency of hydrogen, the most abundant element in the universe. Any civilization wanting to send a message would use that frequency. It's universal. The signal came from the direction of the constellation Sagittarius, specifically a region near the Chi Sagittarii star group. It never repeated. Decades of follow-up observations found nothing. The WOW signal remains the single strongest candidate for an extraterrestrial transmission in human history. And 3I Atlas came from the same patch of sky. Webb checked the alignment. 9 degrees of separation. In astronomical terms, that's practically pinpoint accuracy. A signal in 1977. A physical object in 2024. 47 years apart. He sat back in his chair. The pieces were connecting in ways that turned his stomach. What if the signal wasn't a message? What if it was a transmission confirmation? A message received ping sent back to somewhere after detecting Earth's radio leakage. What if 3I or Atlas was the response? The thing nobody tells you about interstellar travel is the timescales involved. Even at incredible speeds, crossing light years takes decades, centuries. If something was sent from even a relatively close star system, say 50 light-years away, it would take 50 years just for our signals to reach them. Then, however long it took to build and launch a probe. The math worked, terrifyingly well. Humanity's first radio broadcasts powerful enough to leak into space started in the 1930s. By the 1970s, we were broadcasting constantly. Television, radio, military radar. Someone could have heard us. The WOW signal, 1977. Possible confirmation. 3E Atlas arrival, 2024. Physical probe. 47 years of travel time. Webb's hand hovered over his keyboard. He needed to tell someone. But who? And would they even believe him? The evidence was circumstantial, coincidental. But the beam was not coincidental. This wasn't first contact. This was a response. The sun wasn't acting right. Dr. Michael Zhao, solar physicist at the Goddard Space Flight Center, noticed it first. 3 days after the beam event, he was monitoring routine solar activity when something appeared on his screen that made no sense. A sunspot, exactly where the beam had struck. Sunspots are normal, dark patches caused by magnetic field disruptions. They appear and fade all the time. But this one wasn't fading. It was growing, and it was pulsing. Zhao ran a spectral analysis. The energy signature coming from the impact site was completely wrong. Normal solar emissions follow predictable patterns. Hydrogen fusion, helium formation, standard stellar physics. This was different. He called it a resonance flare, not because he understood it, but because he needed to call it something. The energy was pulsing at regular intervals, like a heartbeat, 1.7-second intervals, perfectly consistent. Stars don't have heartbeats. Machines do. Within a week, the resonance flares intensified. What started as minor energy fluctuations became massive eruptions, each one larger than the last, each one originating from the exact same point, the impact site. But here's what made Zhao's blood run cold. The flares weren't random. They were directional. Normal solar flares spray energy in wide cones. Coronal mass ejections spread out across millions of miles. But these resonance flares were focused, narrow, almost like the sun was aiming. On November 7th, a flare erupted and tracked across space in a beam-like column. It missed Earth by 800,000 miles. close enough that satellites on the edge of our magnetosphere registered the radiation spike. One research satellite, EOS-14, caught the edge of the beam, fried instantly. Every circuit melted. $400 million of equipment turned into dead metal in 0.3 seconds. The shielding on that satellite was designed to withstand direct solar storms. This wasn't a solar storm. On November 12th, another flare. This one tracked Jupiter's orbit, followed the planet's movement across the sky for 6 hours before dissipating. The sun was tracking targets. You need to understand what this means. Our sun is 93 million miles away. It's a massive fusion reactor, not a precision weapon. The fact that energy bursts were maintaining coherent beams across that distance, actively tracking moving planets, that requires guidance systems, targeting algorithms, intelligence. The beam from 3I Maud Atlas hadn't attacked the sun. It had infected it. Or worse, activated something that was already there. Every 1.7 seconds, the pulse continued. Like a countdown, like a system booting up, running diagnostics, preparing. The flares were getting stronger. The intervals were getting shorter. Current projections showed the pattern accelerating. In classified briefings, the question wasn't if anymore. It was when. When would a flare lock onto Earth? When would our own star, the source of all life on this planet, become the weapon pointed directly at us? The nightmare scenario wasn't an alien invasion fleet. It was turning our sun into a gun and aiming it at its own planets. And we had no idea how to stop it. Because you can't fight a star. Word count, 435 words. So why haven't you heard about this? Why aren't world leaders on television explaining that our sun has been weaponized? Why isn't this the only story on every news channel? The answer is simple, and it's terrifying. They decided you can't handle it. The meeting happened within 18 hours of the beam event. Secure video conference. Representatives from NASA, ESA, Roscosmos, CNSA, the Pentagon, and intelligence agencies from 14 countries. No minutes were recorded. No official record exists. But the decision was unanimous. Total information blackout. Think about what would happen if this went public. Really think about it. The stock market would collapse overnight. Not a crash, a complete disintegration. Because markets run on predictability, on the assumption that tomorrow will basically resemble today. What happens when humanity learns that an unknown intelligence can reach across light years and turn our own sun against us? Panic doesn't cover it. Religious institutions would fracture. Some would claim divine intervention. Others, the end times. Governments would lose legitimacy because the one thing they promise, security, just became a proven lie. You can't protect people from a star. Civil order depends on the illusion of control. Take that away, and society doesn't gradually decline. It shatters. The thing nobody tells you about classified information is that most of it isn't hidden to protect national security. It's hidden to protect social stability. This isn't about aliens anymore. This is about preventing the end of civilization as we know it. So, the data was buried. Hubble observation logs were classified under national security protocols. The scientists involved were given gag orders backed by federal prosecution threats. Media inquiries about 3I Atlas were redirected to a prepared statement. Minor comet. Broke apart near the sun. No threat to Earth. A footnote. Nothing more. Meanwhile, behind the scenes, the real work began. Every major radio telescope on the planet is now operating under coordinated observation schedules. They're listening, scanning the sky where 3I Atlas came from, waiting for a follow-up signal. Nothing so far. Just silence. Defense agencies are running simulations, wargaming scenarios against an enemy whose technology is beyond our understanding, whose motives are completely unknown, whose next move could be anything. How do you defend against something that can manipulate stars? Answer: you don't. The best-case scenario, and this is what keeps officials awake at night, is that the beam was a test. A probe checking if we're technologically advanced enough to notice. An experiment to measure our response time. We noticed, we tracked it, we classified it, but we didn't respond. What does that tell them about us? Worst-case scenario? The activation sequence in the sun is just the first stage. A weapon being armed, a timer counting down, and we're sitting here, watching our star prepare to sterilize its own solar system, with absolutely no way to stop it. The solar physicists are watching the 1.7-second pulse, monitoring the resonance flares, tracking the energy escalation. Current models suggest the pattern will reach a critical threshold in approximately 7 months. What happens then? No one knows. But the projections, the classified ones you'll never see, suggest the sun will emit a directed energy burst powerful enough to strip Earth's atmosphere in under 6 minutes. Every living thing gone. And there's nothing we can do but watch it charge up. So they decided to let you live your life. Go to work, watch your shows, raise your kids. Ignorance isn't bliss, it's mercy. But here's what they're not telling you. 2 days ago, Atlas detected another object. Different trajectory. Same origin point in the sky. Bigger. It's not slowing down. And this time, 3 more telescopes around the world have gone completely dark. No malfunction, no explanation. Just offline. The 1.7-second pulse from the sun, it just changed. 1.4 seconds now. It's accelerating.